So question 10 wants to know, what's the benefit of using a random sample in the study? So we want to talk about that. A random sample is what allows us to generalize the results back to the population. So what it's going to do is it's going to remove any sort of bias that the samples may have that won't allow us to claim that the sample looks a lot like the population. So anything that's true about the sample should also be true about the population. So A says random sampling balances the possible confounding variables. So that's not what random sampling does, that's what random assignment does. And then B says random sampling is used in order to obtain a sample that is representative of the population. So the correct answer is B. 11 says a sample of 250 people who frequently suffer from headaches were randomly selected from a large medical facility. 100 of these people were randomly assigned to receive new headache medication when they had a headache, and the other 150 people received the old headache medication. The time until the patient reported that they no longer had a headache was recorded. The results are shown below. We know what type of test could be used to determine if there's strong evidence that the average time to relief is different between the two medications. So we have two different samples. One for the old med and one for the new med. And as far as we know, they don't give us any reason to believe that the two results are paired. So we don't have anyone from group 1 who's taking the new medication to compare to someone who's taking the old medication. So if we can't compare someone in group 1 and group 2 directly, we can eliminate a pair test. So what we're actually recording for each person is their time till they no longer had a headache, and time is a quantitative variable. So we're going to use a t-test. Anytime we have a quantitative variable, we're always going to use a t-test. So the only one up here that has two samples and a t-test is B. A two-sample z-test we don't do. We do a two-sample proportion test if we have two different categorical variables. And we do a chi-square test if we have two different categorical variables with more than two categories. 12 says, in the past year, adult bass, a species of fish in Silver Lake, were known to have an average length of 12.3 inches with a standard deviation of 3. So this tells us that mu is 12.3 with a population standard deviation of 3 inches. People who fish often in Silver Lake claim that this year they are catching smaller adult bass than usual. A research group randomly sampled 100 adult bass from Silver Lake, found that the mean of the sample is 11.2 inches, and they estimate that the standard error of this mean is 0.3 inches. So the question is, if the fish are currently no different in size from the past years, how surprising is this difference of 1.1 inches? So what we want to kind of do is we want to create a z-score. Because if a question asks how surprising something is, it's basically it's asking how unusual is the result. We measure how something unusual is with a z-score. So a z-score is going to be our value minus the mean divided by that value is standard deviation. And so what we're going to look for is our value was our x bar. We want to subtract our mean, which is the population mean. Then we want to divide by the standard deviation. Well, the standard deviation of a statistic, either x bar, p hat, the difference between means, difference between two proportions, the standard deviation is our standard error. So they give us a standard error of 0.3 inches. This is going to be 1.1 divided by 0.3, which gives us 3.67. And you want to remember that a z-score above 3 would be considered really rare. So we have a z-score above 3, so we consider it rare, which means that would be very surprising to get a difference of 1.1 inches or more if the mean is actually 12.3. So the correct answer is A. And one of the questions we generally get about this is, why don't we use the standard deviation of 3? So if we're just looking at a single fish, you use 3. If you're looking at an average of the fish, you need to use the standard error, not the standard deviation.